gotta find both of them. You gotta find
The area of a trapezoid is base 1 plus base 2 times the height divided by 2. Number 8. We will have a test probably, maybe next week, coming up real soon over this stuff. Give me a second, I'll try to draw this real quick.
That is really good.
Somebody help me out.
How do you find the area of a trapezoid? Like just up.
Somebody help me out. What's this number?
3.
3.
Like, oh, 3.
Yeah, 3.
That one nothing.
4.
4.
7.
8.
6.
Oh, it's a 6.
That's a 6 there.
And 3.5 is the height.
They give us a height. I can't draw the height in there. It's not going to look right. So is it all right if I just write it out here?
Yeah.
Height's 3.5 of the trapezoid, right? Surface area. Find the surface area. First of all, in this shape, what shape is this? What's it called?
Trapezoid. Prism.
Trapezoidal prism. Trapezoidal prism. What's the base of a trapezoidal prism?
3.
A trapezoid, right? So how many trapezoids am I going to draw?
2.
2. What do we know about them? They're equal. So we find area of one, we'll get the other. What other faces do we have? How many? 4 rectangles. Are they all the same? No. Alright, so we got all those. We need to find the area of each one of those, add them all up. That's going to be our surface area. Somebody was just asking what's the formula for area of a trapezoid. It's this right here, base 1 plus base 2 times height divided by 2. Somebody help me out with this and have your calculators out. Of the trapezoid, which 2 sides are the bases? What numbers?
3.
3 and 7. So 3 plus 7. Remember, the bases of a trapezoid have to be the 2 parallel sides. All right? 3 plus 7, we said the height of the trapezoid was what? 3.5. Divide that by 2. Somebody do all that for us.
$17.5.
17.5. Anybody else get that?
Yeah.
So what's the area of this trapezoid?
17.5.
17.5. This one?
17.5.
The rectangles. Let's do this bottom first. What's the dimensions of that bottom rectangle?
3 by 3.
3 by what? 6. Everybody agree with that? What's the dimensions of this top rectangle? 6 by 7. What's the dimensions of this side rectangle? 4 by 6. Anybody noticing anything? That thickness, that height of the entire prism,
It's always going to be 6.
it's always going to be 6, and it's going to be in every one of these rectangles. All right. So what's the dimensions of the other side? 6 and 4 again. Area of this rectangle. 18. This one. 42. This one.
24.
This one. What are you going to do to find the surface area? So do that. 100 and what? 43. Anybody else get 143? Yes, no, maybe?
Yeah.
Is that what it is? What's our units? Because that's going to be marked wrong on the test next week.
Yard
Yard
squared.
squared.
Yard squared. We better do them all. Yards squared. Remember, area, whether it's surface area or just regular area, always square units.
If we forget to add the units at the end, will we still get a little bit of credit?
Yeah, maybe. I don't know. Depends how nice I feel that day. Right now, I don't feel very nice because,
Really?
yeah. Volume. How do we find the volume?
Big
Oh.
B.
Big B, which is the area of the base of the entire prism, right?
Mm-hmm.
What was the base of the entire prism? What shape?
140. 140.
What, no, the, what shape was the base of this prism?
The rectangle.
A trapezoid.
The trapezoid.
Oh.
And we want the area of the trapezoid. Did we find that?
Yeah.
What was it?
17.5.
17.5. Times the height of the entire trapezoid. Don't go by the height. Is it this height? No, that's the height of the trapezoid, not the height of the trapezoidal prism. The height of the trapezoidal prism is the distance from one trapezoid to the other, which we used. Yeah, that's right. Which we used several times over here. So what was the height of the entire trapezoid? 6. Somebody multiply that for us.
Oh, 105.
105 even?
Yeah.
Yeah.
What's our units?
Units cubed.
Yards.
Yards cubed.
Can we do number,
10.
yeah.
10. So everybody got that one, so I can erase it? Number 10. Somebody tell me what kind of shape it is.
Octagon. No. I was thinking. Not an octagon.
It's not an octagon, tell me what kind it is.
It's a hexagonal prism.
Hexagonal prism.
Yeah.
Hexagonal prism. Oh, mine looks horrible.
Perfect. I won't judge you.
Yeah, mine looks like it's upside down compared to theirs. Let's do this. Why did it do that? Previous. Oh, because I hit the wrong thing, didn't I? We know it's an octagonal prism. What's the base of the entire prism then? A what?
Hexagon.
Or hexagon?
Yeah.
Sorry, you guys got me saying octagon. So, how many hexagons do we have?
2.
Yeah, sort of ugly, but. How many rectangles do we have?
6.
What do we know about all the rectangles? All the rectangles this time happen to be all the same. Let's do the rectangles first. Somebody tell me what's the length and the width of each rectangle? 8, 9, 8, 9, 8, 9, 8, 9, 8, 9, 8, 9. So the area of this one is, this one? Now, for the hexagon, remember the formula for area of a hexagon is P times little a divided by 2. What's the P stand for? Perimeter. What's the little a stand for? Apothem, good. So somebody help me out. What's the perimeter of our hexagon? How do you find the perimeter of that hexagon? Add up all the sides. How many sides does it have? 6, and each one's how long? 8. So 6 plus 6 plus 6 plus 6 plus 6 plus 6. 48. So the perimeter is 48. What's the apothem?
6.9.
6.9. Everybody agree with that?
Yeah.
Divided by 2. Do that math.
48 times 6.9. Divided by 2.
So I'm going to write down 300 and something.
Yep. Wait, what? Oh, well, I got that.
You can get 300 and something.
Wait, let me.
I'm just upset with Owen here because he's making up numbers and he's got a calculator in his bag that he's just.
I got one
That was a series.
Yeah, I got
165.6.
165.6. I was so confused.
When he said that, I was like.
So Luke, when you get confused, look at who's throwing out the answer and look and see what he's actually doing or she's actually doing at that point.
Okay.
Right? Because my friend Owen here is throwing out answers, but he didn't have a calculator in his hand. Do you really think he can do that math without a calculator?
Yeah, his noggin's pretty big.
I know his brain is huge, but it's not big enough to do that without the
It's big
calculator.
enough to remember, cause I did this problem last block, and I got like 600 something, so I said 300.
What's this other hexagon?
So.
165.6.
165.6. What's your question, Branson?
Piece for perimeter, right?
Let's help Branson out again.
Yeah, perimeter, after.
How'd you get to perimeter?
Adding up
I
both
don't know.
sides.
Perimeter.
Add up all the sides
Six
of the hexagon, right?
So it would be 8 times 6. It would be 8. Yeah. Okay. And then you're just talking about happening, which is the 8.9 or 6.9.
Can I get a volunteer to move up here next to Branson and every time they see him off in his own little world? Because didn't we just explain all that?
Yeah.
And we did a pretty good, every time you see Branson off in his own little world, slap him in the back of the head.
I'll do, I'm down. If you down.
Branson, stay with me, please. Do we have all that now?
Yeah.
Yeah.
So what are we gonna do next?
Add them all up.
And 763.2.
Point what?
Two.
2, what's our units?
Units squared. Is there no? I don't see any units.
There's no units on that one?
No.
No.
So just units squared, that's our surface area. Volume, is volume difficult? What do you do to find the volume?
165.6
165.6, where'd that come from?
That's the area of the base.
This is a base of the entire prism, right? So that we use that times, and then the height
6.5.
is just the thickness of the shape. What was the height this time? What was the thickness? How tall was it from, or how far was it from one hexagon to the other one?
9.
9, everybody agree with that? Multiply that, what do you get?
1,490.4.
0.4?
Let's start a petition.
1,490.4.
What'd you get?
I got 1,490.4.
Yeah. Okay.
4? Is that what we're going with? What's our units?
Units cubed.
Can we do?
Who's got 4?
Can we
Super.
do
32.
3?
32?
Yeah. I didn't
So
know
okay,
what
well
you
since
said,
you're doing
so
that,
I don't know.
would the pentagon, would that be the same?
Guess what's
um, formula that?
Any of the regular polygons?
Okay.
What?
That's why I couldn't do this, because I didn't write down the formula that you told us right now.
Tell him to put the word bubble.
32, you said, right?
Oh yeah.
A house is 30 feet wide, 62 feet long, and 11 feet tall. If a bundle of siding covers 100 square feet, how many bundles are needed to side the entire house? So we got this house. I'm just going to draw. I'm not going to draw the top of the house.
We don't need the,
Probably a rectangular prism like that, right?
Yeah.
Is what we're thinking. What's this distance? 30?
Yeah.
What's this distance?
60.
62.
62? What's this distance?
30. No.
What is it?
I don't think it gave us.
100 feet?
Oh, 11 feet.
11.
Sorry, I'm on.
So we got all that.
Branson, don't even want that.
Branson, I'm telling you, today you're gonna stay in the hallway. Focus, man.
A bundle of siding covers.
We have all that. We're covering we're covering this with siding. Are we dealing with surface area or volume?
Surface area.
Surface area.
Which one?
We're covering it with siding. so it's-
Surface area, because it's Squared.
So we're covering it,
Yeah.
so we're dealing with surface area. If we were dealing with volume, we'd be dealing with what?
The inside.
How much will fit inside of it. So we just want to deal with the surface area. How am I going to find the surface area of this?
Square down just.
What have we been doing this whole time with
How
surface area?
Yeah, we've been doing.
Draw the nets. Draw off the what? What shapes?
Squares.
All right, rectangles. How many are rectangles?
6.
6 of them.
But we're not putting.
Yeah,
All
we're
right,
not
hold
putting
on.
the top.
And bottom.
Calm down, we'll get to that. So, when we look at this, are we actually using all 6?
No.
No, because are we putting any siding down here?
No.
No, so let's get rid of that side. Are we putting any siding on this part up here?
No.
So let's get rid of that. So all we really want are the lateral faces, the ones around the outside, right?
Oh yeah.
So tell me the dimensions of, I don't know, let's start with the front face here.
30 and.
30 and 11.
30 by 11, everybody agree with that?
Yeah.
What's the dimensions of the back face then?
30 by 11.
30 by 11. How about the dimensions of this end?
62 by 11.
62 by 11. How about the dimensions of this other end? 62 by 11. How are we gonna find the area of each of those rectangles?
Just
Multiply them.
multiply.
So do it for me.
330.
330.
600.
What's the second one?
600.
That's 330.
What's this one? 682.
Yeah.
What's this one?
Same.
This one was easier than the last one.
What are we gonna do with all that?
I don't know. Add it all together and multiply by it.
So add it all together. That's gonna give us the surface area. What's the surface area?
2024 feet squared.
And then divide by 100.
Now, is that our answer?
No.
No, they wanna know how many boxes. So what Owen's saying is 2024 divided by, how much is in a box?
100.
100 square feet.
Yeah.
So how many boxes do we need?
20.
20.24, that's a horrible, horrible answer. Because you're not gonna go out to Lowe's or Menards and say, yeah, I need 20.24 boxes of siding.
So you need 21 bucks.
They're
So
gonna look
we're
at
gonna need 21 boxes.
You said the 20.
It's a horrible,
20.24,
horrible
they're gonna look at you a
number.
little funny. What?
And then they're gonna say, what school do you go to? And you're gonna say National Trail, and they'll say, oh, now we understand.
Oh, there's a problem. Don't hate on National Trail.
Better than the
You're the one
pencil.
teaching.
Maybe one more, I know, that's why it bothers
You're
me so
hating on
much.
yourself.
That's why it bothers me so much that
Hey.
one of you's gonna walk out there and say that to them, and they're gonna,
Be like, oh,
boy, Ebersole's just not doing his job.
Hey.
Next question, it doesn't have anything to do with Branson over here in his own little world. Every
3. It's better to be a blaze.
29. 29, I might do a couple more if you guys actually started working a little bit. 29. On 29, let's, and I can't read that because it's too dark for me. I'm hoping you can see it a little better than I can. For 29, let's do volume first,
Okay.
just because I'm lazy. How do you find the volume of first of all, when we're looking at this, if we're talking about volume, does it matter that one's stacked on top of the other or anything?
No.
No, you still find the volume of one, the volume of the other, and what are we gonna do with
Surface
it?
area does matter, right?
Right, surface area will matter. What are we gonna do with those two volumes? Add them together. So let's find the volume of the top one. They're both rectangular prisms. How do you find the volume of a rectangular prism?
Space times height. Length times width.
Times height, right? What is the length of that top rectangular prism?
6.
6. What's the width?
6.
What's the height?
6.
No.
How do you wait? Where's the height?
9.
Where?
Doesn't matter which one's which, but what do we know about?
Oh.
All right. The distance from here, this edge to that edge is 9, right?
Oh, okay.
So what's that give you?
324 millimeters cubed.
We'll get to that here in a second. The
Oh,
other
no,
one,
yeah, we have to add.
the other one, what's the length of the other one?
15.
15, what's the width of it?
9.
9? What'd you say? 5 or 9?
Let's do 5. You're
5?
right, no.
What's the height of it?
9.
9? Somebody multiply that together.
$675.
Everybody else get that?
Yeah.
15.
Now is that our answer?
No.
It's add.
Add those two together to get the total volume, what's that?
999.
999?
Yeah.
Everybody agree with that? Now let's give the units.
Millimeters cubed.
Surface area a little tougher, not a whole lot tougher, just a little tougher. The top box, let's do the surface area of the top box first. How many faces do we have on the top box? 5. How come just 5 and not 6?
The bottom one
Because,
is
yeah.
showing.
The bottom one's not part of the surface area, is it? So we just need 5 of them this time. Let's do the very top. What's it, dimensions? 6 by 9.
The other one.
The bottom would be 6 by 9 also, but
With
we don't want it, right? So we're not doing it. The right-hand side, what's the dimensions of it?
9 by 6.
9 by 6. The left-hand side,
9 by 6.
9 by 6. So we got the right-hand side, got the left-hand side. We need the front part of it.
That's 6 by 6.
6 by 6. The back side of it that you can't see.
6 by 6.
6 by 6. Somebody find the area of this first one.
54.
54.
54 for the next one.
This one.
54.
This one.
36.
This one.
36.
So that's all the top shape, right? What was the area, even though we don't need it on here, what was the area of the bottom that's covered?
135.
The bottom that's covered.
36.
What was the dimensions? 54, right? I'm gonna do this, because we're gonna use it here in a second. I'm just gonna circle it. Has nothing to do with what we just did there. It's just to show you here in a second. The other rectangular prism. How many faces does it have?
5.
Yeah.
Wait, 1, 2, 3, 4.
6.
6.
Oh, yeah, 6.
It has a
But
bottom.
you have like one of the.
Now it's got 6 faces, and we'll get to the one that's you guys are trying to leave out here in a second. Give me the bottom.
15
What's the
by 9.
dimensions of the bottom? Say it again.
15 by 9.
15 by 9. Everybody agree with that?
Yeah.
Now the tops be the same. We'll leave it blank for a second. We'll come back to it. The front face. What's the dimensions of it?
15 by 5.
15 by 5. Everybody agree with that? How about
Yeah.
the back face then?
15 by 5.
15 by 5.
15 by 5. The one on the right hand side. 9 by 5. One on the left hand side. 9 by 5. Let's find the area. What's 9 times 5?
45.
45. 45. The other one's 45. 15 times 5.
75.
What did you just do?
Because he's got that calculator laying right there and he's still not using it. He's going to yell out answers and not be sure.
I was sure.
That's why you're going.
15 times 2 is 30.
What's
and 30
15 times 9? What's
135.
135?
Yeah.
Now, on the top, do we want the whole 135 on the top part?
9 times 9.
Part of it is covered up, right? The way we get this other one is we're going to subtract off part. Well, what we're going to subtract off is what I circled up here, because that was the bottom of this top shape, right? So we're going to subtract off 54. Well, what do you tell me the bottom of the big rectangular prism was?
81.
Riley just told me it was 135, right? So we do 135 minus 54, and what's that give us?
81.
81. So we got that one shape there, that top, that looks like this, but this part's covered. And we just want the areas of those two parts. And Michael's telling us it is 81. Now, Owen's gonna go, well, you could've went this way and just subtracted this off and got that little box on that side and that little box on that side. And I'm gonna tell him that I think it's harder to find the area of the two boxes than it is just to say this minus this and find the area altogether.
That one was wrong.
Which one was wrong?
What you said. Because 15 is that side, so I just minus 6 from that, and they give me 9, and I just did 9 times 9, which gave me minus 7.
Now, so we don't want the 135, but we do want the 81. What are we gonna do to find the total surface area? Add it all up, so
690 millimeters.
add all those.
squared.
How much?
690
690?
Yeah.
What's our units?
millimeters squared.
Millimeters squared.
Can we do,
And was my way, I know Owen up here is gonna argue with me, but was my way any harder than what you think Owen's way was?
I have no
If you-
idea.
If you see a different way to do it, if you see a different way to do it and you think it's easier that way, then you go right ahead and you do it that way. As long as you're getting the correct answer, that's all I care about.
we do 14.
Number 14. It's probably the last one because I'm tired of being up here.
I could not
Yeah,
understand.
you can't do number 14.
Yeah, I crossed it out.
Pretty sure you can't do it, because they don't give
There's
you
no
the,
like-
Yeah, they don't give you an app.
They can give you an app then?
Yeah, so.
All right, mark it out. I'll let you.
Alright, good.
Even though I think we can do it, but.
And on one of the questions, it's on there twice, so do we have to like copy our answer
There's
over?
2 of them that are on one place.
No.
There's
There's
two.
So you just want to leave them blank. Just leave them blank. That way I can mark them wrong.
16 and 18.
If you know the answers, just write them down. It's not difficult.
Just
Can
change
you
the
do number
units.
19 really quick? Or, no, sorry, number 21.
28.
A triangular prism.
Yeah, I don't know how to find them.
You want to do one of those? Which one?
I just forget.
Which one?
18.
18. 18, last one.
18?
What kind of problem is 18? What kind of figure?
Triangular prism.
Triangular prism. First thing we're going to do, we're going to find the surface area. Surface area. What's the base of a triangular prism? What shape?
Triangle.
Triangle. So it's got two triangles that are the same. Shh. Maybe we won't do this one. It's got two triangles that are the same
3 rectangles.
and 3 rectangles. Are all 3 rectangles the same?
Yes.
Sometimes they are. I'm not sure in this one. They are if the triangles are what shape?
They're
Equilateral.
equilateral, yeah.
All right. And I think this one, if I can see the numbers here. Let's see, that's 14, I think. That's 6, 4, 4. This one, I don't think it's equilateral, so we'll have to figure that out as we go. For the triangles, what's the formula for area of a triangle?
Base times height divided by 2.
What is the base of the triangle? 8. What's the height of the triangle?
6.
6. 8 times 6 divided by 2, what's that give us?
24.
24. Anybody else get that?
Yeah,
So what's the other triangle?
24.
24. The rectangles, let's do the bottom.
8 by 14.
8 by 14, everybody agree with that?
Yes.
How about the, oh, it does have, it's got 2 in there, doesn't it? So it's not,
No.
so it's not equilateral triangle. I see the 2 now, I couldn't see it a second ago. So what's the dimensions of the side going up the right-hand side?
2 by 14.
2 by 14. How about on the left-hand side?
2 by
2 by 14. What's the area of this rectangle?
112.
This one?
No.
Oh, wait.
No. 28, 28.
28, this one?
Okay.
Find the surface area, what are we gonna do?
Add them all up.
Add them all up.
16.
216?
Yep.
Anybody else get that?
Mm-hmm.
What's our units?
Feet squared.
Feet squared. Volume. It's not a rectangular prism, so we can't just do length times width. What formula do we have to use?
The area of the triangle.
Big B times
the height.
H. Big B was the
Area of the
base, which was the triangle, right? So what's the area of the big base?
24
24.
times 4.
The height is the distance from one triangle to the other, even though, again, we don't have to go back through this, right? Even though
Yeah.
it's setting on that side that's shaded, that's not the base, all right? That's actually the height. So how tall is this or triangular prism? 14. Again, one more time. Just to make sure everybody understands this, make sure you're watching. I can find my triangular prism here. We got this shape, and even though this shape is sitting here like this, is that the base? No. Alright, is this the height? No. The height of the triangular prism goes from one triangle to the other. So the distance between my fingers, that's always the height. The distance from one base to the other base, every single time. Somebody multiply those two, what do you get?
336.
Isn't that Owen's barn right there?
What's our units?
Feet cubed.
Feet cubed.
I think we got top of one more.
Yeah, we know that statement's wrong, don't we, but first two words in the statement he just made.
What is that?
Yeah, we know we got time to do one more.
Make sure your names are on them, you go lay them on that big desk over there.
I might keep it this
Oh wow, you're just so kind.
Didn't grab the notes, grab them.
You pick up.
That's how we do it. Are you tall? This isn't fair. I got the like a height advantage shoes too.
Height
They got
advantage.
the turf. They got the turf on the bottom. Give me like a whole extra inch. Yeah. My bad. I thought that was fun.
No flying things. When do we want them? Yeah.
Oh, I get it.
Hey, let's not.
Next week. Hang on, run one over yet. So I'm not sure if I'm gonna take it yet or not.
I thought it was fun. I thought it was.
You've not got on my nerves too completely bad yet, but
Two completely.
there was a couple of times there where 10 seconds after I said, this is how you find the area of a regular polygon. You asked then, how do you find the area of a regular polygon? And we had to go back through the whole spiel again. So that sort of got on my nerves.
That was the one time, right?
It seems like there was one other time, but we'll go with
It's
that.
okay. He does that in basketball too.
Well, I don't.
Yes, you do.
Why is everyone gotta bring up basketball when they're talking about it? Come on, man.
What other sport do you play?
Got it.
Why you gotta bring
Dang.
up a sport?
Just saying.
Sport.
On these surface area and volumes of cylinders, spheres, cones, pyramids, most of them not too difficult because you just have to use the formulas. We're going to write down a couple of things with a few of these that I want you to put next to each one in your notes. So I'll give you a second to get each thing down there. We're going to do the examples on the other page together.
Binder.
Is there supposed to be something by if no top? Mr. Ebersole? Is there supposed to be something by if no top?
Okay, we're gonna write it here in a second.
Yeah.
Make sure these formulas are on your formulas packet. So if you don't remember where they're at in your notes, use your formulas packet, they're on there. Or you can't read your own writing when you write it down here. Look back at the formulas packet to make sure that you're getting it right. The first thing here on this first one, surface area of a cylinder. Talked about this. This would be the net of a cylinder. Talked with it talked about last class. Hold it up. That's a cylinder. What shapes do we have?
2 circles and a rectangle.
2 circles and a rectangle. On your notes, I want you to write this down. This part right here, that's the rectangle. So that part of the formula, 2 times pi times radius times height, that's just the area of the rectangle.
How? I mean, like, why do we have to use pi? Like, is it because it's in a circle? Like,
So what it's doing, to explain to Kellen here, what it's doing, it's actually finding the what of the circle? The circumference. Because that circumference of that circle is actually going to be the length of the circumference of the circle. That distance is actually going to be the length of the rectangle. Alright, and then the height of the cylinder is also the height of the rectangle. So that's where it comes from. This part, if that's the rectangle part, then this part is the what?
Circle.
The 2 circles. So write that in your notes. That part, the 2 times pi times radius squared, is just the 2 circles. A lot of times when we're dealing with cylinders, they don't have a what? Top. Alright? When we deal with cylinders a lot, they don't have a top because we want to be able to put stuff inside of them. A cup, a bucket, all that stuff. So with this, if we're doing surface area, Kellen's right. What's it going to be? What's the formula for surface area if it doesn't have a top?
2 pi r height
2 times pi times radius times height plus pi times radius squared. Instead of 2 circles now, if it doesn't have a top, we just have what? 1 circle. So you just get rid of that 2 right there. If it doesn't have a top, does that change the volume of it? No, it's still how much will fit inside of it. So volume is just pi times radius squared. If I get rid of that h, pi times radius squared is the area of a what? Circle. So all you're doing here, as you're doing this, you're seeing how many circles. If we filled this all up with little slices of circles, how many of those circles does it take to fill up that entire height? That's where the h comes from. So you're taking the area of the circle times the height, and that's telling you how much will fit inside of it. On this one, this bottom one for volume for a sphere, let's rewrite it. Volume equals 4 times pi times radius to the 3rd power divided by 3. Write that in your notes. All I did, instead of having a fraction out front, because those fractions seem to confuse a lot of people, write it that way. And then all you're going to do is, I'm telling you to write that down so that, because you were off in your own little world again. And when you do that formula, you multiply 4 times pi times radius to the 3rd power
Divided by 3.
And then take that answer and divide it by 3. And that makes it a little easier. When you get to the third power here, you might even want to do this. Instead of having that formula, maybe I even write it like this to make it easier. On Owen up here, I put 4 times pi. Radius to the third power means radius times radius times radius. Then divide by 3. So when you're plugging it into your calculator, you just put in 4 times pi, whatever the radius is, times the radius again, times the radius again. That way you don't have to worry about, hey, how do I get to third power? Those of you who want to get to third power, there's either this button on your calculator, little caret button, and you put in whatever the radius is, hit that button, and then hit 3, and it'll do it. Or there's this button on your calculator. Y with an X as the exponent.
Or X with a box.
You put in 4, and then hit that button, and then put 3 in for the X, and it'll do it. But now that I'm telling you all that again, which way is probably the easiest way?
Radius.
Radius times radius times radius is probably easier than trying to search out that button on each calculator. For surface area, anybody notice anything about the surface area formula of a sphere? Same thing as a circle, except
It's 4 circles.
it's 4 circles. So if I took a sphere, if I took a softball has started for the ladies here at Trail. If I took a softball and I cut the cover off a softball and I cut it up, guess what it would make?
4 circles.
4 circles, exactly 4 circles. Now, is it just gonna, if I just cut it off and lay it out there, is it gonna, oh yeah, there's 4 exact circles there? No, you'd probably have to piece it together a little bit, but it would make 4 exact circles that are all the same size.
Don't they come together like that?
Yeah. So the parts that come together that they sew look something like that, right? And what you'd have to do is you cut it, but then you say, well, then you got these little extra parts here. Yeah, those parts would actually have to be added on somewhere, and then the other ones. But if we did it exactly right, it'd make 4 congruent circles, 4 circles that are exactly the same. Next one's cones.
You're gonna be lost on codes. First time you see a code, you're gonna be like, what is this?
No, we have them on our formula page.
That's true, but
Like you're gonna look at that.
we're going to write several things down with a cone. Cones and pyramids, probably the 2 hardest things, just because the formula's little crazy.
Jeez. Square root, radius, square plus I squared.
This formula down here again, easier way to write it, volume equals
Pi r squared times height divided by 3.
that might be a little easier to do on your calculator. First thing extra that I want you to write down with this, and make sure you're writing this stuff down because you're going to be confused on these and pyramids. H stands for height, and I know you're probably thinking, well, we already know that, and I hope you do. H stands for height, but height's got to go through the middle of the cone. S
Slant.
stands for slant height.
Isn't there a slant height in triangles too?
Pyramids. And the slant height goes down the side of the cone. Two different things. This is the height, so if I'm standing up here, Ethan O, the great adventurer, standing on top of this cone, he wants to get down to the bottom, he drops a rope down to there. It's going to make the height of the cone. Hopefully, right? Because you don't want it to end right up right here and you have to jump that far.
Why can't I just slide down the cones?
Because that wouldn't put you inside the cone.
I don't want to be inside the garden.
What if there was?
So then, if he doesn't want to be inside and he's over here and he slides down the side, he's no longer sliding, he's not sliding the height, now he's doing the slant height.
What if Libby down?
So slant height goes down here, height goes through the middle, radius of the circle's down here. How many circles are in a cone?
Enough.
One. On the cone formula for surface area, write this in. Pi times radius squared, that stands for what?
Circle.
The circle. And then pi times r times s stands for
The cone.
the cone part of it. Alright? Cone part. I don't know how else to say that. The cone part. My pen's not writing very well.
Cone with a big.
On this one, this stands for the circle. This stands for that cone part of it. So if we don't have a bottom on a cone, a lot of times cone doesn't have a bottom, an ice cream cone doesn't have that part, the round part on it, right? Because you want to put the ice cream inside of it. So what would the formula there be?
Pi RS. Right.
Pi times radius times slant height.
Or pi R.
Times.
The square root of R squared plus B squared.
Now, Luke was throwing a fit when he seen this formula here, because it is a crazy formula. So the other thing that I want you to write down here, and I'm going to give you a second,
Why would you use that though?
because if you know on this one, let's do that.
Like if you don't know.
Why would you use this formula? When would you use this formula? If you know what?
Slant height.
The slant height. When would you use this formula?
If you don't.
When you just know
The radius.
the regular height. So if you know the regular height, you have to use this formula. If you know the slant height, you have to use this formula. Now, to try to make it a little easier on you, and this doesn't necessarily make it easier, it's still an extra step. Maybe you don't like this big long formula here.
Gonna use.
So I'm going to do this. Can I erase all that? Everybody have all that? Write this down somewhere on there. A squared plus b squared equals c squared. If we wanted to find the slant height here, if we didn't know the slant height but we knew the regular height, what you do is you put in, for A, you put in the height, so h squared plus, for B we put in the radius of the circle, and that's going to give you the slant height squared.
Does it make a triangle?
So, yep. So if we look at this, what kind of triangle do we have right there?
Right.
A right triangle. So if we wanted to find the slant height so that we could use this easier formula, we could just do that.
You'd find the hypotenuse.
Find the hypotenuse. And then that's going to tell us the slant height, and then we can use that easier formula. So if want to find the slant height.
Okay, so we use the top formula if we do have it, and the bottom one if we don't have it?
Right.
Okay.
If you know the slant height, then this is the easier formula. If you just know the height, not the slant height, then we have to use this formula. Well, if you don't like this formula, then we could always find the slant height by using that, by using Pythagorean's
You should
theorem.
write those formulas anywhere.
No. You got them. You got them. You wrote them down now. You got them.
How do you not
Use
remember
with-
A squared plus B squared?
I'm talking about the other ones, Ethan.
They're on the notes.
Thank you, Ethan.
Use with
Yeah, I
slant.
forgot what these are in this list.
I'm starting to like you a whole lot more than everybody else.
Even me.
Wow.
Branson. Is that really a
Are
question?
you really allowed to say
Three.
that?
Right! Pyramids!
Are you saying like I'm like better than everyone?
No.
I'm confused.
You keep on asking, he's gonna hate you more.
This why is she laughing?
I'm listening to you.
Are we gonna be able to have like a paper with these formulas for like the state test?
Sometimes they give them with all those formulas on them. Sometimes in the past they haven't, so I can't answer that until we get all the stuff in.
Can I just bring my binder?
No, they won't let you do that.
Why would they not give you the formulas? They won't even give you everything.
So, sometimes I don't know if they look through the test and decide, hey, this time they need these formulas and that's the ones they give or what. Because sometimes they give. I remember one year they gave every one of these almost everything that's on that formulas packet that I gave you was on the sheet that they gave you.
That'd be good.
Along with Pythagorean's theorem, sine, cosine, and tangent, all that stuff was on there. Then another year, all that stuff wasn't on there. So I don't know. It just
Maybe it's a
depends.
pattern.
Last year for the algebra test, they gave us all these formulas.
Yeah, and we didn't have to use a single one of them.
We should
Not single
strike. If
That
they don't
was
give it to
weird.
us. We should just.
Well, they do that because they just make up one sheet for algebra and geometry. So
Oh.
everybody gets that sheet, so.
Everybody.
Pyramids. For a pyramid, for surface area, there is no formula for surface, there is a formula for surface area. We're not gonna learn it because it's a pain in the butt, all right? Surface area, you're gonna do what we were just doing with surface area of all the prisms. You find the area of each face and add them all up. To do that, you might wanna write down for a triangle, what's the formula for area of a triangle?
Base times height divided by 2.
Base times height divided by 2. Make sure you remember that, because a pyramid, all a pyramid is, sort of like a prism. A pyramid has one base, whatever that base is, and all the rest of the faces are what shapes? Triangles. Now if it's a square pyramid, like this one is, what's true about all these triangles?
Are equal.
They're all the same. Does it always have to be that way?
No,
The
sir.
pyramids in Egypt, not square pyramids. The base is a rectangle. Alright, so it's called a rectangular pyramid.
What if we had a pyramid ice cream cone? You could go to work.
Sure.
You're just gonna ignore
It would break really easily. Like,
With this for volume, again, I would change this. B equals big B. What's big B stand for again?
The
Base
area of-
Base.
Area of the base, which is whatever that is. A rectangle, a square, could be a pentagon, could be a hexagon, could be anything. So you find the area of that base and you times it by the height, then you divide that answer by 3.
just because it is 3 dimensions? Why is it?
It's by 3. It's sort of the same thing as triangles divided by 2, because a triangle, if we're looking at a rectangle, that's base times height, right? Well, if we're looking at the triangle here, we only want half of it.
Okay, so how would we?
So with a pyramid, what they're telling you is, if this was a rectangular prism, if it was a whole rectangular
You
prism,
could fit 3 of those.
you
in.
could fit 3 of those pyramids in there. So you'd have, this one, you'd have one here, and you'd have one here. So you're dividing it by 3 because you only want one of them.
Okay.
Same thing as on the other one, slant height goes down the side of the pyramid. Regular height goes right through the middle of the pyramid. Alright, so you need to know both those. And again, let me erase some of this, pointer options, erase everything. If I do this,
Make a triangle.
What kind of triangle?
A white
A
triangle.
right triangle. So could I find this distance down here?
You're,
Yeah, I could do the height squared, plus whatever that is, squared, we'll call it x squared, equals the slant height squared,
that's like the.
using Pythagorean theorem, and then I'd subtract off the height and get x squared and figure that out, and that's gonna tell me this. Now, with this, if I find that distance, let's say we figure it out and we figured out it's 10. What's this distance down here? 20. It's just double, because when you drop that rope, when Ethan drops that rope down in there to hit it, it's going to be right in the middle of the base of that pyramid. Now, if it's a rectangular pyramid and we find that slant height, does that mean this slant height on this other side is going to be the same?
No.
No, if it's a rectangular pyramid, then the slant heights are going to be different. These two sides over here, should have not put down my pyramid. If it was, mine's a square pyramid again, so you got to use your imagination. These two slant heights are always going to be the same. These two slant heights are always going to be the same.
That was kind of awesome.
All right? But not all of them. If it's a square pyramid, all of them are going to be the same. Or if it's something like this one down here, anybody know what this is called?
A hexagonal pyramid?
Hexagonal pyramid. How come it's called a hexagonal pyramid?
It's got a base of a hexagon.
The base is a hexagon. Guess what's true about all the slant heights there?
They're equal.
They're all the same.
That's
If this hexagon is regular. All right? If it's a equilateral hexagon. On the worksheet, the practice ones, look at those. Have your calculators out so you can help us. Let's look at number 1. Yep.
So, when we do the height first, then you start with the surface.
I don't think you could square root. So on this one, the cone. That's your first answer, cone. Next, surface area. Somebody help me out. For surface area, what's the formula?
Well, do we know the slant height?
I don't know. No, we don't know the slant height.
Then we have to use the bottom one.
All right, so what's that formula?
R squared plus
Pi times radius squared plus
pi times radius, and the square root of radius squared plus height squared.
pi times radius times the square root of radius squared plus height squared.
Yeah,
Is that right? Everybody agree with that?
I think so.
Now, you guys looked at this formula and you think it's all real difficult. It's not as hard as it looks because your calculator is going to do most of the stuff for you. Pi, what is the radius this time?
7.1.
So times 7.1 squared. The problem that you guys have is you've got to write this out the way I'm writing it out now. Otherwise, you get confused. What's pi again? Or I'm sorry, what's radius again?
7.1.
7.1 times the square root of, what's the radius?
7.1.
7.1, we gotta square that, plus what's the height?
19.3.
19.3
Square.
squared, sorry.
7.
Thank you. Now, grab your calculators, and I'm gonna explain to you how to do each one. Branson, quick coloring, and grab your calculator.
Is the last one 19.3 squared?
Don't laugh, Branson,
Yeah.
because remember, you're still wanting me to do you a favor, and I'm still thinking,
I don't
he's
think
getting
you
on my
should do it.
nerves. So when you- Ethan, you think he's getting on my nerves?
What'd you get?
So I probably should do it.
Yeah.
If you do this, I would not try to punch all of this into my calculator as one thing. This is the way I would do it, so that you can hold your calculator and some of you already got the answer. You're going to say, that's what I got anyway. Then fine, do it that way. All right? But listen to what I'm telling you now, and then that way you won't have trouble, because you're going to get to the test and say, Well, I did it that way every time and it always worked out. Well, it didn't this time. I don't know. I would type this in first. Square root 7.1 squared plus 19.3 squared, and then close the parenthesis. And then hit equals. Has everybody got that answer on their
I
calculator?
got 20.
I don't care what the answer is. So let me go over it again. Square root 7.1 squared plus 19.3 squared, and then close the parenthesis. Alright? Hit equals. I don't care what that answer is, just keep it right there on your calculator. Then we're just going to work backwards through the rest of this. So you got that answer on your calculator, right?
Mm-hmm.
Then you hit, why not, Ethan? Do it. We're going to wait on Ethan to do it. I'm going to do it one more time. Square root 7.1 squared plus 19.3 squared, close the parenthesis. Hold on. Yeah, if you close, maybe you don't need to close the parenthesis on yours. I don't know. Some calculators do, some don't. Ethan thought I'd look away and just forget all about it. So, 1 second. I gotta keep my eye on it, because otherwise he's gonna stop on me.
Twice
Why are you asking questions?
Did you work
I am.
Once we have that answer, watch. Once we have that answer, now you just hit times 7.1 times pi, hit equals. All right, everybody with me to that point?
Mm-hmm.
Plus 7.1 squared times pi, hit equals.
Hey, but I got that answer before.
What did it come out to be?
617.1.
Yeah, right.
Does everybody agree with that?
Yes.
What was our units?
Meters.
If it's surface area, still square units.
I got 617.1 before. I just did the rest of this stuff.
So do it, that's fine.
Oh.
When I did the rest of the stuff, I had like 400,000.
I like that you the answer and then you put all that stuff in.
No, I got it.
Yeah, I had 617.
So do it the way you did it then, that's fine. Next one, or I'm sorry, the volume. What's the formula for volume?
Pi radius squared times height divided by 3.
Volume.
So we got pi, what's the radius? 7.1
So do we have to find the height if they don't give it to us?
times, yeah, what's the height?
19.
19.3. Normally, they'll give you the height. It's the slant height that they normally don't give you. So sometimes it may be the other way around. So type all that into your calculator, all the top, hit equals, and then divide it by 3.
143.5. Is that what you got?
I got 1,015.
If you divide it by 3.
I put 1,000. Yeah, I got the same thing.
Okay.
What is it?
1,019.
Alright, what's that last number on top?
1,019.
Pi times.
What did I just do? I did not get what anybody. No, I didn't divide it by 3.
19.3.
So pi times 7.1 squared times 19.3, hit equals. Make sure, on the top, make sure you hit equals. Alright? If you don't, the calculator is probably going to tell you the wrong answer. Then hit divided by 3.
That's squared by 7.
What did it come out to be? Tell me one more time.
1,018.8.
1,018.8.
What's our units?
Meters.
Meters
Cubed.
Oh, man.
For volume, it's cubed, remember? Everybody handle that?
Yeah.
I just wrote that, okay.
Number 2. What kind of shape we got in number 2? Pyramid. And it should say this. Oops. One eraser. Other options. Pen. Put this on your paper. I forgot to do it.
Square.
It's a square pyramid.
Well, for surface area.
So for surface area, is there a formula for surface area? No. So for surface area, what you got to do, you got to find each face. Well, the base is what shape?
Square.
So 4 by 4. What's the area of that base?
16.
16. All the other 4 faces are what?
Triangles that are 4 by,
Triangles.
and it's 4 on the base,
4 is the base, and what's the height?
10,
10.
so they're each 20.
So it's base times height divided by 2. 4 times 10 is 40 divided by 2. So each area is 20. What do we do with all that?
Add them up.
96. Anybody else get 96? What's our units? Centimeters squared. Oops, squared. Surface area. How about volume of a pyramid?
1/3 of base times height. So base times height.
Base.
Base.
Base times
Big
height
B,
divided by-
right?
Yeah.
Big B times H divided by
3.
3.
So 16.
What is the area of the base for this one?
16.
16
times
times the height.
10.
Is the height 10? That's the slant height, isn't it?
So we gotta do the thing where we do the thing.
So do we know the height?
No.
So this time we have to find the height. We're going to draw it down through there, over to here. So I have that triangle. You might want to draw that right triangle out here. What's the length of the hypotenuse in that right triangle? 10. Be careful. What's the length of this side? 2, because it's half of 4, right?
Oh,
So
okay.
it'd be 10.2.
Nope. Well, I don't know.
It has to be less than.
No, yeah, it's got to be less than 10. All right. So when we do it, remember it's 1 leg squared. Tell me a leg.
Okay.
No. What's 2? 2 squared. What's the other leg? X. And I'm going to put S. What's S stand? Or no, I'm not going to put S. I'm going to put H. What's H stand for?
Height.
The height equals, what's the hypotenuse?
10.
And we're going to move this to the other side, right?
We should figure, we should,
So H squared equals, what am I going to write? 10 squared minus, remember when we did that? Punch all that into your calculator. And then take the square root, and what's it tell us H is?
4 root. Oh wait, no, I corrected.
Ethan says 9.8. Anybody else get that?
9.8, yeah.
So what's the height of this pyramid?
9.8.
9.8. So 16 times 9.8, and we still have to do what? Divide by 3.
52.3.
Anybody else get 52.3? What's our units?
Centimeters cubed.
So the pyramid's easier than the cone.
Easier formula,
And it's squares and
except
triangles.
for surface area, doesn't have a formula, you just gotta do all that stuff. But if you think that's easier, then,
Because the cone isn't a shape when you go forward.
yeah, it sorta is, it looks like this.
That's not. Those ones are triangles and squares. That's
That's
all.
extremely hard to do.
Yeah, I mean, when you put it like that, but if you have the formulas, you don't have to mess up the formulas. Just gotta put it in.
Somebody help me out, what do we have, what shape on the next one?
That's a cylinder.
Cylinder, so write that down. Surface area. We got a formula for surface area, don't we?
Yeah.
Oh, yeah.
So for surface area, instead of me writing out the formula, let's plug in the numbers as we go. 2 times pi times 6.5. What was 6.5?
The radius.
The radius, how'd you get 6.5?
Because it only gives us the diameter.
So the diameter is 13, so the radius would be 6.5. So 2 times pi times 6.5
Times 10.2.
times 10.2. What's 10.2?
The height.
the height,
Plus 2 circles.
plus
Plus
2 times pi times
6.5
6.5 squared. Now I'm gonna tell you, on this formula, you can type all of that into your calculator just like I have it written right there. So try that, just type everything, 2 times pi, all the way across, it'll do all of it,
It'll
just
do-
that way.
Will it do it right?
Yep. You type it all in, just like it is right there, and it should give you the correct answer.
265.5.
What does that
I
two
got
do,
682.
what does that two do in?
I got 682.
2 doing where?
Yeah, I did
Four,
something
five.
wrong.
That?
Yeah.
There is, that 2?
Yeah.
There's no 2 there?
No, I was just wondering what that was.
Yeah, I
Oh,
did
it's
something
just, it's in part of the formula.
Then shrink it.
That's
Is it
the
more or less?
rectangle.
It's just multiplying it by 2, so it's saying, when you have this,
You can get rid of that.
if we only did this, it'd only be half of it, so we want double.
Well, never mind.
Alpha
It's, watch, circumference equals 2 times pi times radius. The circumference of the circle is that formula?
Or diagonal.
That's the formula there.
I just don't know what the two's doing.
Well, or the other formula was, pi times diameter,
And radius
right?
is.
So, instead of pi times diameter, 2 times the radius is the diameter. So that's where the 2 came from.
You get rid of the surface area. I did it wrong.
What'd it come out to be?
682.
Even?
Point 0.
0.0? What's our units?
Centimeters squared.
Because it doesn't round.
So, listen, I'm gonna explain that, alright?
Pi times radius and radius.
We'll do volume here in 1 second. When we're looking at this first part, the first part of that formula is the rectangle, right? So we need to find the circumference of the rectangle. Well, one of the formulas, formula we use most of the time is diameter times pi for the rectangle,
For the circle.
or for the circle, all right? For the distance around the edge. But another formula, because diameter is the same as 2 times the radius, another formula is 2 times radius times pi.
I just don't see what.
And that's where that 2 comes from, is because they're using this formula instead of the other. Volume! Don't put everything away yet. Volume! How do we find the volume of that?
Pi times 6.5 squared times 10.2. Divided by 3.
10.2. Divided by 3?
I think, no, do we not do that here? I don't know, I wasn't.
So, somebody do that for me. What is it?
No, we do not. It's 1,353.8.
What's our units?
Centimeters cubed.
Centimeters cubed. That's how much will fit inside it.
Putting the two
Guys scream about volume.
Senior
So if you don't like, if that 2 there bothers you in the formula, instead of putting 2 times pi times r, in that formula put diameter times pi.
Is the diameter just
The whole distance across.
oh, okay.
Senior Ebersole.